Hello everybody, and welcome to our lesson on section 4E, exponential equations using logarithms. So in earlier lessons, we solved exponential equations by rewriting equations with the same base. But it's not always possible to do this, so instead we can use logarithms to help us. We did a little bit before, we're going to do a little bit more now. So for example, I've got these expressions here where I want to solve for x, giving an exact answer in base 10. Now, I know that there's no exact exponent, not whole number exponent that I can raise 3 to and get 20. So I know I'm going to have to use logarithms to help me. Okay, so I'm going to start by taking the log of both sides. When I do that, I can apply my log rules to bring that x down in front as a factor, and that gives me x log 3 equal to log 20. Then I can divide out log 3 on both sides to give me x by itself. That leaves me with x equal to log 20 over log 3, or we could call this log base 3 of 20. I'm not going to rewrite it that way because they asked for the exact answer in base 10. That's why I use logarithms in base 10 instead of the natural logarithm with base e. I can do the same thing with this question here. 3/4 x equals 0.1. I'm going to take the log of both sides. That's going to help me drop that exponent in front. Okay, so I get x log 3/4 is equal to log of 0.01. Oh, sorry, 0.1. Okay, and I can divide both of those sides by log of 3/4. Now, one thing we might not realize in this little green note here, log of 0.1, remember that's the same as log of 1 over 10, or log of 10 to the negative 1, but this is log base 10. So remember, through cancellation law, the 10 and this 10 can cancel out, leaving me with just that negative 1. We can also use natural logarithms to help us. If I have a base of e, I would probably want to use the natural logarithm. So if we look over here, I can take the ln of both sides. I'm going to take the ln of e to the x, that just gives me x. And when I take the ln of 1000, that is my answer. I don't need to plug that into my calculator because we wanted an exact answer. Okay, you do have a ln button on your calculator, but we want an exact answer here. Here we're taking the ln of e to the x over 2, and that's equal to ln of 5. I want to take ln of both sides. That's going to help me drop that x over 2 in front as a factor, and that's going to leave me with ln e, which I know is just 1. That's why the ln disappeared here. On this side, I just have ln 5, but I decide to multiply both sides by 2 to cancel out the 2 in my denominator. So I end up with x is equal to 2 ln 5, which could also be written as ln of 5 squared or ln of 25. Both of those are good exact answers, but this is a little simpler. And then for part C, there's a lot going on for part C. Okay, so for part C, notice that I brought everything to one side and made it equal to 0. Now I'm going to do a kind of a dirty trick. I'm going to multiply all the terms by e to the x. When I do that, I get e to the x squared, I get 2e to the x, and that gets rid of this e to the negative x. It leaves me with just minus 3. And I can see that I kind of have a quadratic equation. It might be clearer if I use this change of variable technique here and just call e to the x a. Then I can see I have a squared plus 2a minus 3 equals 0. That's easy for me to factor, and those factors are easy to set equal to 0. However, I get this answer a equals negative 3. But remember, I didn't care about a. I cared about e to the x. So I'm going to replace that a with e to the x. And I know that I can never get a negative value. There's no value of x that can go in for this exponent that can make e to the x equal to negative 3. So this is impossible or inadmissible. This one is not inadmissible, though. E to the x equals 1. And so I replace the a with e to the x. Now I have ln of e to the x equals ln 1. Okay.